Okay, here's warm-up number 10. We're going to graph a quadratic function that's in standard form, not in vertex form like we had been doing earlier in the chapter. Okay, so it's a little bit of a different process. So finding the y-intercept, what I'm going to do is plug in 0 for x. So I'm just going to write y here, but if you wrote f of x, that's fine. But I'm plugging in 0 for x in both positions. And then I'm going to solve this, okay? Now, 0 squared is just 0, so 2 times 0 is 0. Negative 4 times 0 is also 0, so all that's left is the negative 6, okay? So that is my y-intercept. And it just so happens that the y-intercept is always going to be the c term. Now, that only works if this is in standard form, so don't use that shortcut if you're in vertex form. So that's the danger there. So if you're not sure, just plug in zeros, okay? And then for x-intercepts, I'm going to plug in 0 for y and solve this for x. So just plug in a 0 for one of the variables, and the variable that's left is going to be the intercept you're looking for, right? So here I've only got x's left. This is going to give me an x-intercept. So I'm going to I'm going to factor this in order to solve for x. Now I'm noticing there is a common factor. 2 goes into all three terms, so let me factor that out first. You could actually also just divide the whole equation by 2. That would work here. But the thing with that, you only want to do that when you have an equation, when you have 0 on it equal to 0. So you wouldn't want to do it if it's just an expression. Okay, so I've got the 2 out there. All right, now let's factor the trinomial further. I'm going to use a diamond problem here. I've got negative 2 and negative 3. Looking for two integers that add to negative 2 and multiply to negative 3. So let's see, there's not too many options here. The one that works is this one, right? So 1 and negative 3 in either order. There's my factors. Okay, now I'm going to use the zero product property. I got three things multiplied together that equal 0. So one of these products has to equal 0. 2 can't equal 0. 2 doesn't equal 0. So I'm just going to ignore that part. So it's got to be one of the other two factors. So either this one or this one. And then x would, I don't know why I was using pencil, but I'm subtracting 1 here, running out of space, and 3. So hey, those are my x-intercepts. Okay, let's start putting the stuff into the graph as we go for the last problem. So y-intercept at negative 6, okay, and then x-intercepts at negative 1 and positive 3. Okay, so I'm getting a pretty good idea of what this parabola is going to look like. I also know this is going to open upwards because the x squared term is positive. Okay, so I'm thinking, yeah, okay, this could work out with a parabola opening upwards. Vertex would have to be somewhere down here to make that work. Okay, all right, next up, let's find the axis of symmetry. So there's a little formula for that. X equals negative b over 2a. Okay, so remember this is A and B and C. It's just the numbers are, and the signs have to go with them, right? So there's A, B, and C, okay? So here I've got negative, the opposite of negative 4. So negative 4 over 2 times 2. So that would be 4 over 4. That equals 1. So the axis of symmetry is not just the number 1. It's x equals 1 because it's going to be a line. It's the line that divides my parabola in half. Okay, so it has to be a vertical line. It has to be x equals something. So you need the x equals in there. Okay. Now another little shortcut, another way to find this. If you already have the x-intercepts graphed, it's going to be halfway between them. So I can kind of visually do this and think, well, what's halfway between these two numbers? They're 4 units apart. So, hey, it's got to go through right there, right? Which would be the line x equals 1, which is exactly what I got with the formula as well. Okay, so there's my axis of symmetry. Okay, now the axis of symmetry is the middle of the parabola, and that means that the vertex is going to be on the axis of symmetry. Okay, so when I'm looking for the vertex, it's going to be an ordered pair. I already know the x coordinate has to be 1 because x has to equal 1 if it's going to be on this line. So it's going to be 1 something. Okay? So my goal, my next task at least, is to find the y that goes with that. And what I can do, I can go back to the original equation and plug in 1 for x to find the y that works with it. Okay, so I'll do the exponent first. Negative 4 times 1 is negative 4. Okay, so then I'll do the subtraction. That would be negative 2 minus another 6 is negative 8. Y equals negative 8. So that's the y coordinate when, sorry, I'm off screen. When x equals 1 in this equation, y is going to equal negative 8. There is my vertex. Okay, and let's try plotting that. And hey, this is looking good with what I got here. Okay, so let's graph this. You could sketch it right now. Also, this y-intercept, if you wanted another quick point that you can get, any point, you should be able to reflect it over the axis of symmetry. So I'm seeing that's 1 unit away from the axis, so I can just go 1 unit out the other side like that, and I got myself a 5th point. And now I can sketch the parabola. Okay, and you know, it doesn't have to be super beautiful, but if we plotted those points neatly, then you'll be able to indicate that you understand what's happening, even if your parabola doesn't look the greatest. Okay, that is it for today. See you next time.